Alright, first thing we're going to do is, now this section is a law of sines, but what we're going to do is find the area of a triangle. And again, like I said earlier, you're probably wondering why in the world is area of a triangle in a lesson with the law of sines. It seems kind of weird, doesn't it? Do you remember back in the day? Who knows? It was last year, wasn't it? Didn't we do area last year in geometry? Sure. Do you remember what area of a triangle is? That's one of the easiest ones. You probably knew that even before geometry, didn't you? Do you remember what that is? 1/2 the base times the height. So the area of a triangle, I'll put a little t there for triangle, is 1/2 the base times the height. Okay. Now in geometry, we got a little more specific with this. We talked about the base and the height. Do you remember the relationship that the base and the height have to have? In order for it to be a base and a height, does anybody remember that? Say it. Say it again. Perpendicular, yes. They're got to be perpendicular to each other. Do you remember that? So if I had a right triangle, for instance, let me grab this right triangle here and put it over just so you can remember. Watch. If this is a right triangle right here, and I call this the base, okay, which one is the height? Is it this one right here? No, it's this one right here. Why is it this one? Well, when you're a little kid, before you took geometry and learned what perpendicular was, you'd say, well, it's the straight up and down one, or something. You know, you'd refer to it something like that. But when we get into geometry, we get a little bit more specific. We say that the height and the base have to be perpendicular. So on a right triangle, the base and the height are already two sides of that triangle, isn't it? So you just look at it, you plug it in, multiply them together, take half of it, and you've got the area of that triangle. Well, this is not a right triangle, okay, and that kind of has to do with the law of sines. Remember the law of cosines? We're trying to find sides and angles when they're not right triangles. We're going to do the same thing with the law of sines. We're trying to find, different sides, different angles if we don't have a right triangle. Because if we did have a right triangle, what would you use to find the missing sides and missing angles? Yeah, just the trig functions. Could use Pythagorean theorem, right, if there's two sides. Or you can use the trig functions. But if you have a non-right triangle, then we have to have other ways to do it. So law of cosines was one that we talked about yesterday, I guess it was. And then we're going to talk about it today, law of sines. So you can kind of see how it relates, because we're talking about finding the area of a non-right triangle. Well, we got to find the height of it. Well, let's do this first. Let's call this the base. Actually, yeah, I'll just call that. I'll tell you what, I'm going to label it. I've got notes on this, so let me just write down all my sides. Okay, so we'll call that side A, B, and C. Now, C is not necessarily the hypotenuse, is it? Because we don't have a right triangle. So I just arbitrarily called any of these sides A, B, and C. And then, of course, if this is side A, this is angle A. If this is side C, across from it or opposite would be angle C. It's a little bit bigger because it's a capital letter. And this is side B, and this would be angle B. I was watching a YouTube video last night on a teacher doing law of sines or something, and he would call this baby A and baby B and baby C. I was like, I don't think I could do that. That would just be kind of weird, wouldn't it? And he called it big B. Big B, I guess, is okay. And then another teacher, all right, again, I was geeking out last night. Another teacher, I don't know if they were a college teacher or high school or what, but they would call this side A, but they would call this angle alpha, and they would call this angle, instead of B, they'd call it beta, which are Greek letters of the alphabet, kind of like theta, and a lot of math people do that. They use the Greek letters. And then opposite C, they'd call it gamma. It was the weirdest thing. It's like, why not just call it A, B, and C? Wouldn't you agree? I guess it's so you don't have the confusion between side A or baby A, I guess. Yeah, the C's, you're right. That definitely, I could see a difference right there. But as long as you draw that a whole lot bigger than that one, I think you can figure it out. So anyway, I just thought I'd show you what was out there, because sometimes, I'm thinking, you're making this way more confusing than it really is. Well, you probably think that about me half the time, don't you? So let's do this thing. What we want to do, let's see, we want to find the area of this triangle right here, and there's several ways you could actually write the area. Now, instead of writing A, I'm going to write area, because we have an angle A right there, just to make it. Now, it's going to be 1/2 the base times the height. So we could consider any of these sides right here to be the base. Let's just do it one way, and I'll just kind of show you. Let's just consider this one right here to be the base. Since it's already letter B, it's kind of sitting on it, right? We always like to use the one that the triangle's sitting on, the side that it's sitting on, as the base. So we call that the base. What is the height, though? Is the height A? Is the height C? No. What did we just say? The height has to be what to the base? Perpendicular to the base. All right, so we don't see. So one of those sides is not the height, is it? but we can actually draw the height. So if this is the base right here, where would you draw the height? From angle B? Yeah, to side B, like right there. Is that the height? Perpendicular. Not straight down. What is it? I mean, I know what you're saying when you say straight down, but to be a little bit more proper, we'll say perpendicular. Is that okay? So that would be the height. So we'll call that height. All right, so what we're going to do is we're going to write an equation. It's going to be, let's just go back to black. It's going to be 1/2 the base times the height. Well, we know the base is B, so we can just keep that right there. But what about H? What if you didn't know H? What if you only knew the sides of the triangle? Okay. How would you find H? Well, let's take a look at this. Let's take a look at that angle A right there. Look at H. Now we know A, B, and C. All right. We don't know what H is, but could we solve for H using this angle right here? What trig function would you use if you use this angle and we're trying to find what H is? What do you think? You've got a right triangle right here, can't you? Or don't you? So you can.
Give the sides of the triangle.
And you know the sides of the triangle. A, B, and C you know. You don't know what H is.
Sine.
And you know what the angles are. So use a sine, right? Because watch, this is opposite over hypotenuse. Everybody see that? So opposite over hypotenuse is the sine. So what we can do is this. What am I trying to do? I'm just trying to find out what H is, correct? So let's just write this off to the side. So the sine of angle A is equal to opposite over hypotenuse, H over C. Well, what can we do? We can get H by itself now, can't we? So what's H equal to? C times the sine, C times the sine of angle A. So what are we going to do with that? We're going to take that and put it in right there, and we're going to rewrite the area. So watch, area. Now you're not going to have to do this every time, okay? This is something that you can have memorized, just showing you how they got to it, okay? If you can't memorize it, you could always go back to this and figure out how to do it, all right? So what are we going to do? The area of this triangle is what? It's 1/2 times the base. Remember, we know these sides of the triangle. We're saying we know what they are. So 1/2 the base times the height. Well, what is the height? It's C times the sine of angle A. That's the area of that triangle. Now, you don't have to go through all this every single time, do you? You don't have to go through the perpendicular and trying to figure it all out. You can just look at this and then just write down the equation. Look, it's 1/2 BC sine A. Look at the two sides. If you know what angle A is, if you know what angle A is, and what sides do you use? You use the other two sides, don't you? Side A is not involved in this at all. So if you're doing angle A, you're not dealing with side A, you're just dealing with what? B and C. So we could do this. Remember, I said I was going to write this several different ways. What if you're dealing with angle B? We could go through this whole thing, drop a perpendicular and all that. We're not going to. We can just kind of look at this and see what's going to happen. What would the area be? Let's say if we knew angle B. Right? Now we know all the sides, and let's say we know angle B this time. So what do you think it's going to be? If we know angle B, sine of B, what do you think these two things are going to be? Yeah, A and C, correct? You just use the other two sides that is not across or is not opposite this angle right here. So that's another way you could write it, depending on which angle you know. Really, you only need to know one of these formulas, okay? Because it's not always going to be A, B, and C, but they do this in the book, so we'll do it. And this will be what? 1/2. What do you think? We got BC, we got AC. What do you think we have now? AB sine of what? Angle C. Good. All right. So you could look at it any of those ways. I'd probably just pick one of them, and you can just remember. It's not too hard to remember. If you know this angle A, then use the other two sides. Okay, the two sides that are not opposite. All right, they would be the adjacent ones, wouldn't they? See that? B and C would be adjacent to angle A, so you can think of it that way. I guess you could think of some big fancy way to say it, but I think visually we see what's going on. Does that make any sense? Let's do a quick example, okay? And then we'll go on to the lost signs. Okay, here's an example. Got a triangle. Just change the triangle up a little bit. You can do this with any of them, but watch. We've got this angle. I didn't even label these A, B, and C or anything, did I? All right, but remember the whole idea of finding the area of this. So the area is equal to 1/2 the base. Which one do you want to call the base? 9. Okay. Now what do we do now? Times what? Remember, this is This is the angle, so we're going to do what? Take the sine of the angle, right? And what sides do we use here? We use the other two sides, the adjacent sides, correct? The one that's not opposite this angle. So we don't even know that side, which is good for us because we're not even going to need it. So we just put the 9 and the 8 right there. See how easy that is? And that's it. You don't have to draw any perpendiculars. You don't have to do any trig. We've already done it once. You don't have to reinvent the wheel every single time, do you? So you just plug everything in. So the area... No, you don't have to draw it because that's incorporated within this formula right here.
I mean, not draw it. Do you have to put another 9 in? Because the 1 9's the base. And then 8.
No, that's it. Yep, it's these two because one of these was the side. Let me just write down the answer. It's 34.9. And it's centimeters, so it's areas, so it's centimeters what? Squared, right? And that's it.